So there are some wonderful shapes that we can see in the plane. Some of them we're very familiar with, and they all come from looking at a cone. In fact, these particular shapes are known as conic sections because basically they come from taking a cone and slicing the cone with a knife or more particular, with a plane and seeing what the result is. Now, some of these shapes are very familiar. For example, if we were to take the cone and make a slice with a plane that would be actually sort of parallel to the floor, then can you see what the cut would be? The cut would actually be a circle. So in fact, a circle is an example of a conic section. It's what we get when we take a cone, like an ice cream cone, and cut right along here. You can see that way up here too if you want, and you can see a perfect circle by taking a cone and cutting it like this. But there are other shapes we can get. In fact, if you take the cone and cut it sort of skew with a plane, then you're going to get not a circle, but you're going to get sort of an ovally circle, or what we call an ellipse. Similarly, we can actually cut a piece off like this, and if we cut a piece off like this, then the object we get actually is a perfect parabola. So a parabola is another example of a conic section. And finally, if you imagine for a second having two cones, so imagine a cone that comes up like this, and then another cone that comes up like this. So imagine taking two ice cream cones, having one inverted and one going the right way. If I were to now slice just like this, I would hit part of the wing of the top, which would be sort of pointing up like this. And then when I cut down, I would see part of the wing of the bottom part coming down like this. So I'd have a piece like this and a piece like this, and that's actually a hyperbola. Another example of a conic section. So conic sections actually come in many different shapes, but they're all very important and all quite beautiful. Let's take a look and see if we can identify certain conic sections just based on a formula. So let's take a look at the first formula. Here we go. X squared plus y squared equals 9. And I want to see what kind of conic section we might want to guess this to be. So there's lots of ways of doing this. One way is to actually graph it. We could actually graph it using a graphing calculator if we wanted to. And it's sort of not that difficult. Now, to graph something like this on a graphing calculator, we first have to solve for y and then insert the function as y equals stuff, and then we can see the graph. So first of all, let's just solve this for y. So if I were to solve this for y, I could subtract x squared from both sides. And if I were to do that, I would see y squared equals 9 minus x squared. Okay, and now I'd like to solve this for y, so I sort of want to take the square root. But remember, I need to take both the positive and the negative square root. And so I see y equals plus or minus the square root of 9 minus x squared. Now, there's no plus or minus to put in on the graphing calculator. So in fact, we have to plot this in and input it as two different functions. The plus function and the minus function. So what we graph are actually two functions. y1 equals square root 9 minus x squared, and then y2 equals negative square root of 9 minus x squared. So we have these two pieces, and if we put both of them in and graph it, then we can actually see what we get. Let's take a look and see what we get. Well, look at that. It's a perfect circle. It looks like a perfect circle. So in fact, this is the equation of a circle, and we can actually see where the center is. It looks to me like the center is right at the origin, and so we have a center. So we have a circle. The center is at 0, 0. And what are the intercepts? Let's see if we can find the intercept. So what's the x-intercept? That's what happens when we let y equal 0. So if we let y be 0, I see x squared equals 9. What's the solution to that? There are two of them. You can see it there. So the x-intercept is going to be at x equals plus or minus 3. What about the y-intercept? That's when we let x equal 0. And then we see y squared equals 9, which means the y-intercept is the same value as the x, y equals plus or minus 3. And we see what seems to be a really beautiful circle. Let's try another example together. See if we can identify a different shape. So here, this shape kind of looks like the last one, but now it's 16x squared plus 4y squared equals 64. So let's try this. Again, if we want to use the graphing calculator to sort of see a picture of this, we first have to solve for y. So how do we do that? Well, again, we're going to start off by saying that 4y squared equals, I'm going to subtract 16x squared from both sides, and I see 64 minus 16x squared. I'll divide both sides by 4, and so I see y squared equals 64 minus 16x squared, all divided by 4. And now I'm going to take the square root, but of course I've got to take plus or minus the square root. So y equals plus or minus the square root of 64 minus 16x squared, divided by the square root of 4, which actually is just 2, so I could write just 2 here. Again, if you want to graph that, there's actually two separate functions here. We have to have a y1 function, which is going to equal the square root 64 minus 16x squared all over 2. And then the y2 function, which is the other part, negative square root 64 minus 16x squared all over 2. So we have these two different functions. If we take a look at graphing them both at the same axes, look what we get. Sort of looks like an oval. In fact, this is an example of an ellipse. So this is an ellipse. Where's the center? The center still looks like it's the origin. So the center is still at 0, 0, like it was for the previous circle we looked at. And what about the intercepts? Well, the X-intercept, we let y equal 0, and now we have 16x squared equals 64. What's the solution to that? Well, we see that x squared equals 9, and so what we see is that x equals plus or minus the square root of, what am I saying? So if you solve this here, we see x squared equals 4, and so therefore we see that x equals plus or minus the square root of 4, which is 2. Okay, that's good. Now what about the y-intercept? Then we let the y be 0, and I solve this, and I see that y squared equals 16, and so therefore y equals plus or minus 4. And you notice something interesting. With the circle centered at the origin, the x-intercepts equal the y-intercepts in value. But here with the ellipse, since it's elongated, what we see here is that the y-intercepts are actually different values than the x-intercepts. And that's one of the characteristics of an ellipse. It's sort of elongated in one direction, or in this case, sort of in this direction. And so we can actually see that happening live. And by graphing these particular equations, we're able to actually see what geometric objects we have.